Hello dear students and welcome to part 6 of the previous year question paper. We are on to question number 3D carrying 5 marks, and this is a question from the topic from the module expansion of functions. We are required to show that sine of e raised to x minus 1 equals to this expression. So for this we are going to begin with the series of exponent function. So we say that we know that e raised to x is equal to 1 plus x square over 2 factorial plus x cube over 3 factorial, that's 6, and x raised to 4 over 4 factorial, which is 24, and this goes on. So from here it is easy to write down e raised to minus 1 will be equal to x plus x square by 2 plus x cube by 3 plus x raised to 4 by 24 and so on. Now we will start with the sine expansion, the expansion of sine function. So we also know that sine of x is equal to x minus x cube over factorial of 3, which is 6, plus x raised to 5 over factorial of 5, which is 120, and so on with the alternate plus minus sign. Now, if you will have a keen observation on the problem, then we are supposed to be going up to the 4th power. So you can see that here we have got the 5th power of x, which we can choose to ignore later on. Now in the question we need the expansion for sine of e raised to x minus 1. So therefore we'll call this as equation A, and we're going to use equation A in the just expression that we have written. So we will be getting that sine of e raised to x minus 1. Now here we have an x, so instead of x we are going to write down e raised to x minus 1. Then minus, we need an x cube, so that will be replaced by e raised to x minus 1 whole cube over 6. And as I told earlier that we can ignore this term. Now we also have the values for e raised to x minus 1 from expression A. So we can rewrite this as x plus x square by 2 plus x cube by 3. Sorry, this should be x cube over 6. And so it will be the same here, x cube over 6 plus x raised to 4 over 24. There will be more terms, but again we'll not consider them. And then minus, we'll just factor out the 1 by 6. E raised to x minus 1 whole cube, so that's going to be x plus x square over 2 plus x cube over 6 plus x raised to 4 over 24 and so on whole cube. So this follows from equation A. Now we'll keep the first bracket untouched, so let me just rewrite it quickly. So this is going to be x plus x square over 2 plus x cube over 6 plus x raised to 4 over 24 and so on. Now over here we have a cubic power. So we are going to apply the formula for, means the general formula for whole cube. So it will be like a plus b whole cube, but in this case there are more than 2 terms. So we are going to apply the formula in general for a1 plus a2 plus up to an whole cube. And also bear in mind that we don't want to exceed the 4th power, since that is what we need. So firstly we will start cubing the individual terms. So we'll cube x, so with that will give us x cube. Now if we happen to cube the second term, which is x square over 2, so you will note that the power of x will become 6, and we don't want that term, and hence we are going to ignore the cube of the second term, and thereafter all other terms will have powers which will be greater than 4, so we will be not taking any more cubic terms. Now for the next term we are going to talk about the terms which are of the form 3a square b or 3ab square. So considering x as a and x square by 2 as b, we can write it as 3x raised to 4 over 2. Now if you keep this as a and take this as b, so notice that this will give us power as 2x square, and this is x cube, so x square into x cube will make the power as 5, so we'll not be again interested in that, and hence all other terms we are going to ignore. Now likewise, if this we consider as a, and other terms if we consider them as b, the powers are going to exceed 4, so we don't have to discuss about them. We can just stop at this point and we will just include them all by these dots. Now just for the expansion part, we are going to multiply by 1 by 6 in the second term. So I'm just right now opening all the brackets, so we'll get x plus x square by 2 plus x cube over 6 plus x raised to 4 over 24 and so on, and then we have got negative x cube by 6, and then here we can get rid of the 3's and 6's, so this is going to give us x raised to 4 over 4 and so on. So you can see that x cube over 6 can be cancelled out, so we are having x plus x square over 2, and now we are having the 2/4 powers, so one is x raised to 4 over 24 and this is x raised to 4 over 4. So to get the denominators equal, this needs to be multiplied by 6, so that is going to give us 1 minus 6, which is going to be negative 5, x raised to 4 over 24 and so on. So this is what was expected to do, and we have completed that part. So with this we complete question 3D, and now we can move on to question 3E. So this is question number 3E. It is from the module Numerical Solutions of Transcendental Functions, and we are going to use the Newton-Raphson Method to find the root of the following equations up to 3 decimal places, and the equation that is given to us is 3x minus cos of x minus 1 is equal to 0. So first of all, we are going to declare this function as f of x. So let me say that f of x is equal to 3x minus cos of x minus 1, and we'll also need f dash of x. So let us just evaluate f dash of x here itself. So it is going to be 3 plus sine of x. Now they have mentioned in the question clearly that the roots needs to be calculated up to 3 decimal places. So as you can see on the calculator screen, I'll be fixing my outputs up to 3 decimal places. So here you can see that we are going to fix the decimals up to 3 digits. So that's the first part which you should be doing immediately after reading the question. Set up your calculator requirements. Now we need an initialization. In this case, the initialization is not given to us, so we are going to find out the initialization or the initial root. So for that, we are going to look out for a sign change. So let us find out f of 0 first. Now you could start with any number. We are beginning with 0, and that's a kind of a guess which we are taking. So f of 0 is going to be 3 times 0 minus cos of 0 minus 1, so which is going to be negative 2. Note that it is a negative number. Then let's find out f of 1. It's going to be 3 times of 1 minus cos of 1 minus 1, and this is going to be 2 minus cos of 1. Now please note that we are not interested in the value, we are just interested in the sign that the value has. Now 2 minus cos 1 is equal to 1.460, and that's a positive number, so we have a sign change here. So we will say that since f of 0 into f of 1 is negative, this implies that one root lies between 0 and 1. Now, so we have got two candidates for possible initialization. One is 0 and the other one is 1. So to make a better choice between 0 and 1, let us have a look at a visual representation. So let's say this is your number line, the x-axis. Here we have got 0 and here we have got 1. At 0, the image is negative 2. That means we got to move 2 units down. So this is the image, negative 2. And at 1, the image is 1.460. So you can see that 1.460 is comparatively closer to the x-axis then -2. So to decide between 0 and 1 for the initial root, 1 is the better candidate. So we'll be initializing with x0 is equal to 1. So we'll say that let x0 is equal to 1. Now we are going to state the formula for Newton-Raphson's method. So the formula goes like this. Xn plus 1 is given as xn minus f of xn over f dash of xn. And this formula holds for every whole number value of n. Alright, so now if you will see, we have f of x, we have f dash of x, and we have x0. So using these three values, we are going to go ahead for the first iteration. So before starting the first iteration, what we are going to do is on the calculator, we are going to store the value 1 in x. So we are going to have 1 and then shift, store, and x. So you can see that the value 1 has been stored in x. And now if you will look at the first iteration, you got to substitute n equals to 0 in it in the formula. So this is going to give us xn, which is x1 is equal to x0 minus f of x0 over f dash of x0. So this is actually 1 minus f of 1 over f dash of 1. Now what we will be doing is we are going to store the expression in the formula, that is xn minus f of xn upon f dash of xn in the calculator. So we are going to have alpha x minus, then we have a fraction. In the numerator we have got f of x, which is 3 times of x minus cos of x minus 1. And in the denominator we have got 3 plus sine of x. So this is the expression that the formula is going to give us all the time. And we are going to substitute x is equal to 1, and that value we have already stored in the calculator. So we're just going to press equal to. So once you press equal to, you see that we have got the output as 0.620. So therefore, the first iterative root is 0.620. Now we are going to use this as xn to evaluate the second iteration. So for the second iteration, we are going to use x1 as 0.620, and everything happens on the calculator. So what you are going to do is, this output that you have got, you are going to store this again in x. So I'm going to press shift and then the store button and x. So you can see that the entire expression, the value has been stored in x. So we'll just rewrite here. So we will be talking about x2 now, and x2 is going to be x1 minus f of x1 over f dash of x1, that is going to be 0.620 minus f of 0.620 divided by f dash of 0.620. And now to use the calculator, what you are going to do is you are going to use the navigation buttons and come to the expression where you had entered the function. So this is the expression where we had entered the function. So it depends on x. So what we are going to do next is just press equal to, and the stored value of x, which is 0.620 now, it will get effectively evaluated. So once you do that, you get the next answer to be, you can see it is 0.607. So we get the second iteration, the root to be 0.607. We keep on continuing this process until we get the exact repeated root. So now we move on to the third iteration. You can see that there is a difference between x1 and x2, and it's quite substantial. The difference is in the second place after the decimal. So we got to go on for the next root. So we'll go for x3, which will be evaluated as x2 minus f of x2 over f dash of x2, and it is going to be 0.607 minus f of 0.607 divided by f dash of 0.607. So again on the calci we are going to first store this number 0.607. So shift store x. You can see it's a big expression which it is going. You can see that it is stored in x. And now what we are going to do is again we are going to look out for the expression where we evaluated the value. So this is the expression where we had evaluated the value and we are going to press equal to. So it's loading because it's doing a lot of iterative calculations. So you can see that after almost a minute we have got this answer as 0.607. Now if we will have a look at x2 and x3, then the values are repeated. So we can stop over here. So we'll just say that since x2 is equal to x3, which is 0.607, so this will give us that x equal to 0.607 is a root of f of x equal to 0. So we can stop over here for the complete solution of question 3e. Now on to the last sub question, which is question 3f. So this is question 3f. It is from the second module, complex numbers, hyperbolic functions and logarithms of complex numbers. So we are having express sine of phi theta and cosine of phi theta in terms of powers of sine theta and cosine theta. So to begin with, you can see that the argument has a multiple of 5 for both sine and cosine, and this thing is available to us by the application of de Moivre's theorem. So we are going to begin with cos of theta plus I times sine of theta, the whole raised to 5, and this is equal to cos of phi theta plus I times sine of phi theta. Now we're going to use the binomial expression, the binomial theorem on the right side. So this is going to be cos theta, and then we'll have 5c1, which is 5. This is cos theta raised to 5. Here we will have cos theta raised to 4 into I sine theta. Then the next coefficient is 5c2, which is 10. So we have next as 10 cos cube theta into I square sine square theta, followed by again 5c3 is 10 into cos square theta into I cube sine cube theta. Then 5c4 is 5 into cos theta into I raised to 4 sine theta raised to 4, and the last one will be 5c5, which is 1, and then we will just have I raised to 5 sine theta raised to 5. Now we are going to evaluate the powers of I. So the first term stays as it is, cos theta raised to 5. Then over here this is an imaginary part, so we can rewrite this as 5 cos theta raised to 4 into sine of theta into I. And then for the next term, now we have an I square here, and we know that I square is -1, so this is going to be minus 10 cos cube theta into sine square theta. For the next term, we have got an I cube, and I cube can be written as -I. So this is going to be -10 cos square theta into sine cube theta into I. The next term, we have got I raised to 4, and that's 1. So this is going to be 5 cos theta into sine theta raised to 4. And the last term is I raised to 5, which is equal to I. So this is going to be sine theta raised to 5 into I. Now we are going to write down all the imaginary terms together and all the real parts together. So the real parts are cos phi theta, cos theta raised to 5, and then minus 10 cos cube theta sine square theta, and we also have 5 cos theta into sine theta raised to 4. This is the real part, and then plus I the imaginary part, we have got pi cos theta raised to 4 into sine theta minus 10 cos square theta into sine cube theta, and the last term is plus sine theta raised to 5. And the left hand side is cos of phi theta plus I times sine of phi theta. Now we are just one step away. So what we are going to do is we are going to compare the real and imaginary parts on either side. So we'll say that comparing the real and imaginary part, we get, so the real part on the left is cos phi theta. So cos phi theta is going to be cos theta raised to pi minus 10 cos cube theta sine square theta plus pi cos theta sine theta raised to 4. And for the imaginary part, we have got sine pi theta is equal to 5 cos theta raised to 4 into sine theta minus 10 cos square theta into sine cube theta and plus sine theta raised to 5. And that's all. So with this, we complete 120 marks of the previous year question paper of November 2024, which was asked at the SIES Graduate School of Technology, Navi Mumbai. I hope that this series of video really helps you in your examination and for your other learning purposes as well. If there'll be something which you need from my side, you can always drop down in the comment section and I will try and help you out. If there is any specific topics that you would like me to explain, you could drop down in the comments or you can write an email to me. The email is available in the description. Thank you so much for being connected with me. Happy learning to you once again.